Hey guys, and today I'll be talking to you about the unit circle and more specifically its applications. So I've actually made a video about the unit circle before explaining what it is, degrees, radians, and where this comes from and why it is how it is. So if you're looking for that, definitely check out that video. I will link it down below. But this is a bit more of applying the unit circle to see some patterns or properties of, for example, sine of theta or cosine of theta. Have you ever wondered why sine of negative theta is equals to negative sine of theta, or why sine of pi minus theta is equal to sine of theta? Well, this is exactly what I will be focusing on today in this video. So if you want to review the unit circle as a whole, I definitely suggest checking that video out before coming here. But if you already are a pro at the unit circle, then let's get into it. So you might remember that the unit circle is formed by having this circle with a radius of 1, and then we can build triangles through it where it's a right triangle that touches the circle, so it has a hypotenuse of 1 and it has theta, and in this case I'm using radians right here, so if you want to use this with degrees, obviously you can do so with pi being 180 degrees, and you can convert between the two. So the point on the circle is defined as cosine of theta for the x-coordinate and sine of theta for the y-coordinate. So the properties that I want to be looking at today is how we can have multiple angles giving us the same value for cosine of theta or sine of theta. Because if you give into your calculator sine of 30, it will give you 1/2, or 30 degrees in this case, or sine of pi over 6, it will give you 1/2. But that's not the only answer, and here I'm going to show you how we can have, and I'm going to give you a sneak peek at these properties that we have right here, where they come from, so then you'll be very confident in how to use them for simplifications in equations. So we're going to have these cases where we're going to look at the sine or cosine of negative theta, the sine or cosine of pi minus theta, the sine or cosine of pi plus theta, and the sine or cosine of 2 pi plus theta. It's actually not that much, so let's get right into it. So let's start off with the first one. Let's draw negative theta. That's going to be right here. And negative theta is the same thing as 2 pi minus theta, so just keep that in mind. Well, we're going to have the exact same right triangle, but if we look at our axes, we're going to realize that we're going to have the same cos value for theta, but our sine value is going to be negative because we're going into the 4th quadrant right here, and our y value is negative, which equals to our sine value, which is then also negative, as we see right here. So in our case here, we can say that sine of negative theta is equals to negative sine of theta. But what's going on with cosine over here? Well, cosine, it's staying the same, because even though we have negative theta, we're just flipping the triangle around, which is causing us to still stay in the 4th quadrant, which is still the positive x side and the x-axis. So, on the other hand, cosine of negative theta is simply equals to cosine of theta. Now, let's build another triangle. Let's focus on this second case right here of pi minus theta. Well, we have pi right here, and if we have pi minus theta, we're going to end up with a triangle that has the same properties, so the same height, the same hypotenuse, obviously, but what we care about is the height and the base. And I'll just draw this a little bit better because that did not look the same. So here we have our triangle, and this is also theta, but the angle itself, and remember, the angle itself that we're measuring is always from here, like this, except in the case of negative theta, where we're going the other way, like we've seen right here. And so this angle right here is actually pi minus theta. That's the bigger angle we're measuring, but to use the cosine and sine, we're going to build this triangle right here. And here what we can see is that because it's the same triangle, we're going to have the same cosine and sine values, but here we're going to have negative cosine of theta, sine of theta. And why might that be? Well, because if we have a pi minus theta, we're going to end up in the 2nd quadrant, and the 2nd quadrant has a positive y value, but a negative x value. So we're going to have negative cosine, positive sine. So what we conclude about this is that the sine of pi minus theta is going to equal, as we've seen right here, the original sine. These values are the same. Now on the other hand, the cosine of pi minus theta is now in the negatives, so we're going to have is equal to negative cosine of theta. Okay, let's move on to our third case right here, which is pi plus theta. Well, that's easy. We just draw it like this. We have pi, and we're adding theta to it. And pi is 180 degrees if you're doing this in degrees. So this angle right here will be pi plus theta. I hope my color coding isn't getting too confusing. And again, same triangle, same properties, but just in a different quadrant at this point. And by the way, this arrow is going all the way over here. But I didn't want to block the triangle, but just so you know. And our values for sine of theta and cosine of theta are now going to be, what do we think? Both negative. We're in the third quadrant. Our y values are negative, our x values are negative, and subsequently, so are our sines and cosines. So we're going to have negative cosine of theta, negative sine of theta right here. So what we can conclude about pi plus theta is that sine of pi plus theta is going to be negative sine of theta, and that cosine of pi plus theta is also going to be negative cosine of theta. And now last but definitely not least, let's take a look at 2 pi plus theta. Now this one is actually very simple, and I'll show you just in a second. What is 2 pi? 2 pi is 360 degrees. So if you start at any point in the triangle, if you start at any point in the circle and you spin 2 pi or 360 degrees, you'll just end up right back. So if we are starting off with our original triangle right here, and this is our theta, and we do plus 2 pi or 360 degrees, we'll end up right where we started off. So it's just going to be, again, cos theta, sine theta. So sine of 2 pi plus theta is equals to sine of theta, and cosine of 2 pi plus theta is also equals to cosine of theta. And again, just remember that you're just doing a full rotation and coming back to right where you were. So I hope this was quite useful for you, because where these kind of properties come into place is if you have an equation, so to speak. So let's say that, for example, we know that sine of 0.4 is equals to 8, right? And then we have an equation that we're trying to solve. And at one point in the equation, we end up having a sine of, for example, pi plus 0.4. And knowing these properties, we know that the pi plus theta in the case of sine will give us negative sine. So we'll know this is equals to negative sine of 0.4 is equals to negative 8. And then we can work with something that we know. And for example, if the answer is asked to be expressed in the form of a, we know that that's what it is. You can also have, for example, two variables. If you have the cosine of x is equal to b, and you're working with something where there's a cosine of, and you have something that has, for example, the cosine of pi minus x, you can substitute this to be, as we've seen before, we're going to end up in the second quadrant. We're going to end up in the second quadrant. So this is going to be the same thing as negative cosine of x is going to be negative b. And again, we can express everything with one variable. So these are the properties that we have just named. I have listed them right here for you so you can take a screenshot and use them later on. But remember that all of these are really logical. And if you ever feel like you're struggling or forgetting to remember something, just draw yourself a little sketch of the unit circle, see in what quadrant you will end up in, and therefore see what it is that you're going to have, whether you're going to have a negative sign, a positive sign, a negative sign, or a positive cosine. So right here are the identities. Sine of negative theta is equals to negative sine of theta. Sine of pi minus theta is equals to sine of theta. Sine of pi plus theta is equals to negative sine of theta. Again, we're here in the third quadrant. And sine of 2 pi plus theta is equals to sine of theta. We're doing a full rotation. Cosine of negative theta is simply equals to cosine of theta. We're flipping it, and so our y changes, but our x stays the same. Cosine of pi minus theta, on the other hand, is negative cosine of theta because we end up in the second quadrant and that has negative x values. And then cosine of pi plus theta is equals to negative cosine of theta, where in the third quadrant, still negative x values. And then last but not least, cosine of 2 pi plus theta is simply cosine of theta because, again, we're doing this full rotation. So I hope you enjoyed. And whenever in need, come back to the unit circle. See you next week.